NX CAD software training. Let's see in the today's session about geometrical constraints. So this is the part 1 session. So the next session will be continued by tomorrow as well. So continue watching. Those who have not subscribed to our channel, please subscribe to our channel and keep the notification on so that you will keep getting the notifications as and when it is uploaded. Okay, let's move on to the topic. We are going to discuss about the geometrical constraint. As I said, this is the geometrical constraint button. Here you can go. This is the geometrical constraint button. Here you can see now. If you press C, the shortcut key is C. If you press C itself, the geometrical constraint window will open. Just press C, it will open. Here you can see these are all the options we are going to see. Okay, so this session I'm considering that in 2 sessions actually, because of many options are there, nearly 24 plus constraints buttons are there. To make you confused, I have divided into 2 portions now. Let's see about one by one. Okay, see, by default you can see here this button is turned on. Here also in the settings, this is the geometrical constraints settings toolbar. Okay, dialog box. Here you can see many of the options, whatever the options it is turned on here, everything will be displayed here within this window. Okay, for example, I am turning off all these buttons, means one by one everything will get rid of from this window bar. Okay, you can see now. Got it? So this is the settings what it takes from this settings bar. Okay, whichever the buttons is in the on condition, that one only will be visible in this constraints window. Other than that, everything will get switched off automatically. For example, here there is no fixed constraint is turned off, fully fixed is turned off, so that only those buttons are not available. You can see in the symbol itself, the symbol will look like this. Okay, like a hook, like an anchor, it will be there. So this is a fixed constraint symbol. Okay, this symbol is not here, this particular constraint not included here. Okay, so whatever the buttons it is turned on here, only those buttons only, those constraints only visible here. Suppose some of the constraints are not visible here, means you no need to worry, just turn on the buttons whatever you want, so that only those buttons only will be available here. Okay, now let's move on. Before we get into this topic, I am just turning off this continuous auto dimension, one thing. Okay, this continuous auto dimension I have turned off it. Okay, now I'm going to create one single line. Just to see here what's happening. I have created one line. So this is comes by default in a horizontal manner. Suppose I'm creating one line. See, by default it is taking horizontal. Now I'm going to this particular vertically, so it takes defaultly as a vertical. So horizontal and vertical defaultly it takes. Suppose I wanted to go at an angle, means you can click at any angle. You can do whatever the angle you want. You can just click on the mouse button one, so that it will get created. Here you can see the difference now. See, this is the horizontal line, this is a line at an angle. Okay, now I will create one line vertically also. Now you see, so this is vertically I have created it. Here you can see there is one small symbol is there. In this line also there is one small line symbol. Here also one small symbol, but in this line there is no symbol. What does it mean? Means, see, this line is horizontal, so by default it has taken a horizontal constraint. Here also you can see there is one vertical line, so this constraint is taken as a vertical constraint. See here, this taken as a, if you move your cursor nearby to this, don't select anything, just move to the near to the line, so it will get selected with the vertical constraint. See here, this line by default it got selected with the horizontal constraint, but in this line doesn't have any angle, doesn't have any constraint similar to this, like a horizontal or vertical. It is at an angle, so that this line we have to define with an angle, then only this line will get constraint. Okay, let us discuss about the dimensional constraint later. Now we'll concentrate on the geometrical constraint alone. Okay, as we discussed, this line I wanted to make it as a horizontal, this line I wanted to make a vertical. Okay, so now I'm going for geometrical constraint. So going for horizontal, select this line will become horizontal. Now I wanted to make this line to be vertical, so that I am selecting this line. So this line has become vertical. Okay, Right. Now I'm going to create another two lines here. We'll keep that away. I'm creating one line here. I'm creating one more line here like this. Okay, this line I wanted to make it vertical, and this line I wanted to make it perpendicular to this line. Please remember that this line I wanted to make it vertical like this, and this line I do not want to make it horizontal. This line I wanted to make it as a perpendicular to this line. Okay, let us go. Now vertical line I wanted to make it this line. Okay, I made it. This line I wanted to make this to this line to perpendicular. So that means I have to go for perpendicularity constraint. Perpendicularity I have selected it. Which line I wanted to make it first perpendicularity? That line you select it first. This line I wanted to make it perpendicular to this line. Okay, just to select this. This has got perpendicularity. See now, so this line is completely perpendicular to this line. Okay, whenever there is a change in this line position, line angle, then automatically accordingly this line also will be moved according to this perpendicularity. Okay, so this is how perpendicularity is maintained. Perpendicularity means you can see a symbol here. It is 90-degree symbol. So this symbol will be present. This symbol specifies it is a perpendicularity each other. Okay, let us keep it away. One more line I am creating here. One more line I have created at an angle of this. Okay, both are different angles. Now what I want is this line is at an angle of something. So now I wanted to make this line also to be with the same angle. That means I wanted to make this line to be parallel to this line. Okay, I want to make this line to be parallel to this line. So to do that, go for geometrical constraint, go to parallel, select this line and select this line. Okay, these two lines will become parallel like this. Okay, this is how this parallel constraint will work. Okay, I will do one more time just to see here. I want to make this line to be parallel to this one, means that is also possible. And go for parallel constraint, select this line and select this line. So both are parallel now. Okay. Okay, we have finished the basic geometrical constraints, that is horizontal, vertical, perpendicularity and parallelism. These four we have completed it. Now we will move on to the other one from the beginning. Okay, right. First I will delete all these things. Coincident constraint. Let us say about coincident constraint. So coincident constraint will let you to connect two points. That is what coincident constraint. So now let's see. Geometrical constraint I'm going. So coincident. So I'm selecting this line's endpoint. This line's endpoint should join to this line's endpoint. Okay, so now I'm selecting this so that it got connected like this. Okay, similarly, suppose I have a circle like this. So this circle center point should come to here, means what I need to do, geometrical constraint, go to coincident, select this point and select this point. Okay, suppose I have one particularly I have one arc here like this. Consider that I have an arc like this. Okay, this arc center point should come and rest exactly to this point, means so that time I need to use coincident constraint. Okay, so this point I have selected now. So to this endpoint I wanted to bring it, so I am selecting this. Okay, give it okay, it will get joined here. Okay, suppose you move this line also, everything will get moved along with the arc. This point will move. See here. Similarly, this line whenever it moves along with the center point only, it will move. Okay, correct. Like this it will move. Okay, so this is how constraints work. Okay, let's move on to the other one. So this is about point on curve. Point on curve means nothing. So here I have a line like this. Okay, this line I wanted to touch. Okay, this is the line I wanted to make this line to be contact with this line. So that is what a point on curve. So this line I wanted to make a contact with this line. So that is what point on curve. So geometrical constraint I'm going. So point on curve, I'm selecting this line. So this line have to touch this line. So I'm just selecting this line. See here. So this has got connected here. So now I'm moving this line. So only the other end can be moved. Whenever this line is moving, this parent line also will move. Whenever the parent line moves, this line also will extend. Whenever this line is reduces, along this also will move accordingly. Okay, this is about point and curve. So this point and curve option will work like this. So this point and curve means the point will lie on the line, but it can place that you can place this at any place, but this also free to move at any place. We cannot leave this as it is. This also to be fully constrained. Okay, so the point and curve means the line can be placed on the point, on the line can be placed on a line, but it will move across the line. Okay, this also have to be fully arrested. Okay, all right, I will do one more time. For example, I am placing one point here. Okay, so I have placed one point. This point I wanted to place it on this line, means that time you can go for point and curve. For example, I'm going for point and curve option. Select this point, select this line. So the point has got reached to this line, but we can able to move this point across the line anywhere. This will move only on this line, nowhere it cannot come out actually like this, but even if it comes out also it will go along the same axis only. Okay, this is how this point and curve option will work. All right, let's move on to the other one. So here you can see tangency. It's a tangency means very simple. So I'm creating one circle here. So this circle I wanted to create, this line should touch exactly to this tangent, means you can go for geometrical constraint, go for tangent, select this line, select this arc. So this will get a tangent constraint like this. So even if you move this circle away from this position also, it will be in contact with the tangentially, either with the same line or else in the imaginary position also it will have a same contact. See here, even the line it is shorter, still it remains a tangency with the same projected tangency. We'll get it like this. Okay, so this is how this tangential constraint works. We'll see one exercise about this. I will create one more circle now for our understanding purpose. So I wanted to create this circle to be tangent to this circle, means what we can do, go for geometrical constraint, select this circle and select this circle. Okay, this will have a tangential constraint between these two. Suppose I want this circle to be touched to this line also, means tangentially you can select this arc and select this line. So it will have a tangent constraint even now also. For example, I have created one circle here. I have created one more circle here to the bottom and one more circle here little bit away from here. Okay, 3 circles I have created it. All are in different places. Okay, all right. I wanted to make everything to be in the horizontally. I wanted to align all the circles should align in a single line. That means in the same center axis across the line. I wanted to maintain it, means that time you can coplanarly. I wanted to maintain all these center point, means that time you can go for horizontal alignment. Okay, so now I am going to select this point. I'm going to select this point. See, now these two has become coplanar. Now I wanted to do for this case. So this one should constrain to this in a horizontal constraint like this. So all these 3 is inline to each other. So this is how this horizontal alignment will work. You can see now I'm moving this line circle, it will move in a single entity. So now geometrically it has got arrested in a horizontal alignment. Similarly, I wanted to go for 2 more circles. I will create it here and another place. I will create like this. Okay, so these 2 circles I wanted to align vertically like this. That means vertical alignment I wanted to use. So geometrical constraint I am going, so vertical alignment I am going. So I am selecting this and I am selecting this. So vertically it got aligned like this. Similarly, suppose I wanted to align this one, means vertical constraint. Okay, this one I am selecting and this one I am selecting. So vertically this has got aligned. So this is how this vertical alignment will work. Whether is it applicable only to the circles? No, it is not at all applicable only to one entity. It can be used for anything. For example, I am creating one line here, one more line I am creating here. These 2 lines I wanted to make it inline to each other, means you can go for horizontal alignment. Now horizontal alignment I went, select this line and select this line, both will become inline now. Similarly, vertically also you can do that. For example, I have a line like this. I do not know what is the angle of this line. Suppose I have one more line like this. Both these lines, I wanted to make it alignment like this. Vertically, I wanted to make a alignment means, see, and this is at an angle, but even though I'm selecting vertical alignment for this one and as well as for this one. So what's happening here? You see, so between these 2 points, it has got aligned, not the line. The line not got aligned, between these 2 points got aligned. See here, you can move this line at anywhere, but this alignment is happened between these 2 points. Okay, so this is how this alignment will work. Let's say about midpoint constraint. So I'm going for geometrical constraint now. Going for midpoint. Okay, select this line's end point, select this line's middle point. Okay, or else you can select this line directly. If you select it, so even though the middle point snap point is on, even though you select midpoint, it won't get connected each other because of this line's end point is connected imaginarily to this point, but however it is not touching each other. Why means the length of the line is already defined here so that it is not touching each other. Suppose I'm moving this line little bit away means, even though if I move also, see now I'm moving this line, the point where it connects, it is connected to the midpoint only. Like this it will behave. So to avoid such a confusions, what we can do is we'll go for one more constraint, geometrical constraint, coincident, select this end point, select this middle point. So this is how we have to constrain. So for generally for any midpoint constraint, you need a 2 constraints. Okay, this is how the midpoint constraint can be given. Say here the midpoint is also given here and coincident is also present here. Both the constraints are have to be given. Okay, for example, now I will create one more circle here. So this circle I wanted to, this circle center point should reside exactly to this midpoint means, going for midpoint constraint now. I am selecting this midpoint. I am circle center point, I am going to select it. Okay, the circle center point should lie on this middle point of this line means, what I am going to do, I am going for midpoint constraint. Already I selected it. I am selecting this line either at any one end. Even though you select it, it has got connected to this midpoint. Now this circle have to sit on this object means, then we have to use one more constraint. It is either point on curve, you can use it, or else coincident, you can use it. Now I am going for point on curve. Select this center point, select this line. Since already the midpoint is defined here, so it will come directly to this middle point only. Okay, right. So this is how the midpoint constraint works. So now I'm going for collinear constraint. Collinear constraint means here I have a line like this. Just think of like this. Here I have one more line like this. Okay, both are at a different angles, but I wanted to align these two in a coplanar, in a collinearity wise. Collinearity means both the lines will reside on the same coplanar. That means same horizontal alignment kind it will work, but it is not a horizontal alignment. Horizontal alignment will consider the points to constrain, but here the line's angle is constrained. Okay, so for example, geometrical constraint I'm going for collinear. Select this line and select this line, both will become collinear like this. Whenever there is a change in this line's angle, automatically this line also will keep changing. See here, this is how this line will work. So this is the line's endpoint. Even though it is away from each other, it will align with reference to this line's angle only. Okay, this is different, and vertical and horizontal alignment is completely different. Horizontal alignment and vertical alignment will work based on the points, end points of the line, but this will work based on the angle of the line, and the angle of the line, or else we can say, is a coplanarism. For example, now I will do one more time. See, I have a line like this, I have one more line like this. Okay, I wanted to constrain this line in line to this, so that means I want this line to be collinear to this line. Okay, to do that, what I'm going to do, go for geometrical constraint, select this line, collinearity I have selected already, select this line and select this line. both will become collinear like this. So the collinearity symbol is look like a equal symbol like this. Okay, this is how the collinearity will work. Okay, so the remaining set of options we will see tomorrow. Hope you understand today's session. If you are not subscribed till now, please subscribe to the channel and keep following me. So let's see in the next class. Thank you.